Hey guys, welcome. We got another UH quiz on the line, our first one for the second semester. Yay! Alright, let's keep going. Riemann sums, integral properties. So this one says compute the lower Riemann sum for the given function x squared in the interval -1 to 1 with respect to the partition. Now notice it says lower Riemann sum. This is not tested on AP, guys, but it's nice to know. So I'm going to draw this graph, x squared, and I'm going to exaggerate it. Here's x squared. And here's -1, and here's 1. So lower Riemann sum between -1 and -1/4. The lowest point happens at -1/4. So there's my first rectangle. The next point between -1/4 and 1/2. The lowest point occurs at 0. So here's my second rectangle. That's right, you don't really have one. The next one is at 3/4 here. And lower Riemann sum at 1/2, it's the lowest. And then at 3/4, it's the lowest. So I'm just going to calculate those three. And here we go. So the difference between -1 and -1/4 is 3/4. And the height, so it's going to be -1/4 squared plus 0. That's this rectangle. The difference between 1/2 and 3/4, that's a 1/4. And then you go times 1/2 squared plus the difference between 3/4 and 1/4 is 1/4. And 3/4 squared. Sorry guys if I'm being soft. If I'm talking soft, it's because I'm trying not to bother Cortez because she's working on her essay. Alright, here we go. So 3/4 times 1/4 squared. When I square that, guys, 3/4 times 1/16 plus 0 plus then 1/4 times 1/2 squared is going to be 1/4 plus 1/4 times 9/16. I'm going to come up here, guys, to finish this deal off. 4 times 16, let's see, 16 plus 16 is 32, and then another 32 is 64. So 3/64 plus 1/16 plus 9/64. Multiply this by 4/4. So 3/64 plus 4/64 plus 9/64. So 9 plus 4 is 13 plus 3 is 16. So 16/64. And that reduces to 1/4. So there you go. Yay. Alright, we got one out of the way. Let's keep going. Compute the lower Riemann sum for the given function. So you have 2 minus x squared between the interval 0 and 1. So let's exaggerate 0 and 1. So here it is, 2 minus x squared. I'm going to say 2 is, alright, let me draw. 2 is like right there. There you go. And 0 and 1. So lower Riemann sum. So we're going to find the lowest point between 0 and 1/2. So the lowest point is 1/2. So there it is. And then the lowest point between 1/2 and 3/4 is 3/4. And then the lowest point between 3/4 and 1 is 1. So I have 3 rectangles, and that's what I'm going to find. So let's find that. So the width is 1/2. And then the height is, let's see, 2 minus 1/2 squared. Well, why did that one come out like that? There we go. And then plus the difference between 1/2 and 3/4 is 1/4 times 2 minus 3/4 squared plus, and then another 1/4. And then 2 minus 1 squared. Alright, let's see what that is. 1/2 squared is 1/4. 2 minus 1/4 is 1 3/4. Let's see. 1 times 4, 5, 6, 7. So 7/4 times 1/2. Plus, and then 3/4 squared is 9/16. And 2 minus 9/16 is 23/16 times 1/4, And I'm going to turn that into a fraction, 23 over 64. And then 2 minus 1 is 1, so 1/4. And let's see, this turns to 7/8 plus 23 over 64 plus 1/4. And when I do that, let's see what I get. 95 over 64. And there we go, guys. Alright, let's keep going. This one says, again, it says lower Riemann sum, so it seems that I got the quiz that loves lower Riemann. So lower Riemann sum, sine x, so 0 and pi, so they're being kind of nice to me. So here's pi. Sine of 0 is 0, sine of pi is 0, guys. And then pi over 6 is probably closer to the 0 than the halfway, than the halfway mark. And then 3 pi over 4, here's the halfway mark. 3 pi over 4 is halfway between pi over 2 and pi. And then pi. Okay, so we're doing lower Riemann. So lowest between 0 and pi over 6 is 0. Lowest between pi over 6 and 3 pi over 4 is pi over 6. And then lowest between 3 pi over 4 and pi is 0. So I'm just going to calculate this one rectangle, guys. So 3 pi over 4 minus pi over 6, this is the width. And then the height is just sine of pi over 6, which is a half. So 3 pi over 4, 3/4 minus 1/6 is 7/12. So this is 7 pi over 12. And then that times a half turns to 7 pi over 24. There you go, guys. Yay. Alright, now we're getting some good ones here. Estimate the integral of 5x squared by the left endpoint. So this is LRAM with 6 rectangles. Okay, I'm going to exaggerate. This is just a quadratic, the function 5x squared. So here is my quadratic equation, exaggerating it. And I'm going to say here, I'm going to say that's 6. So I'm going to create, I guess, like, if that's 6, here's 0. So let me use red here. 1, 2, 3, 4, 5, and then 6. So LRAM, here's my first rectangle. Second rectangle. Third rectangle. Fourth rectangle. Fifth rectangle. And sixth rectangle. See? So now I'm gonna find all that. The width of each rectangle was 1. So all I really got to do is just 1 times 5 times 0 squared plus 1 times. I'm not going to put the 1 anymore, guys. As you can see, they all have a 5. So maybe I can factor out a 5 if you want to do that. Plus 5 times 2 squared plus 5 times 3 squared 5 times 4 squared plus. Sorry, I put the square there because the 6 was there. 5 times 5 squared. And I think that's it because that's 5. And yep. So I'm going to factor out the 5. Here we go. 1 plus, let's see. Well, first I guess technically it's 0. 0 plus 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Let's see. I'm just going to 25 plus 16 plus 9 plus 4 plus 1, and I get 55, and then 55 times 5, and I get 275. So 275. Yay. Let's go to the next one, guys. Same thing, this time with midpoint. So I'm going to exaggerate the graph. There's my exaggeration. Here is 6. So I'm going to say 1, 2, 3, 4, 5, and then 6. And since I'm using midpoint, I have to use the middle. So the middle, right there. Boom, boom. A little above, a little below. Middle, 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 and middle. There you go. The width of each one is 1 again, guys. So they're kind of being nice to me. And I'm just going to do the 4 times the m squared. So 4, why is it not working there? 4 times the middle between 0 and 1 is 0.5. So 1.5 squared plus 4 times 1.5 squared plus 4 times 2.5 squared plus 4 times 3.5 squared plus 4 times 4.5 squared plus 4 times 5.5 squared. So that's 5.5, that's the number. Okay, I'm going to factor out a 4, and I'm just going to type it in like that in my calculator. So, let's see, 0.5 squared plus 1.5 squared plus 2.5 squared, 3.5 squared plus 4.5 squared plus 5.5 squared. And then I get 71.5, and I'm going to multiply that by 4. So 286. Cool. Alright guys, here we go. These are the kind of fun ones. Area between 0 and 1 of f of x is 4, 0 and 3 is 2, 3 and 4 is 3, and then I'm going to find 0, 4. So in order to find the area between 0 and 4, let's see, I'm going to have to do this. I'm going to have to use this one and this one, because if I add those two, where this one stops, this one continues. So the integral from 0 to 3 of f of x dx plus, where this one stops, I better continue. So this one starts 3 to 4. See, so these two match. That where this one stops, this one starts. Equals, and let's see. So 2 plus 3, so we got 5. All right, let's keep going. So on this one here, they want 4 to 2. So let's see, what are we gonna have to do? So we're gonna have to do. So first, I want to find this one first. So I'm gonna go. I'm gonna do this: 0 to 3, f of x dx plus 3 to 4, f of x dx. That's going to give me the area of the curve from 0 all the way to 4. And then, so if I have the area from 0 to 4, and I subtract the area from 0 to 2, that's going to give me the area from 2 to 4, which is what I want. As soon as I get this area from 2 to 4, I can just use the property of switching my limits and putting a negative in the front. So let's do that, guys. So I'm going to do step 1 first. Step 1. The area from 0 to 3 is 1, plus the area from 3 to 4 is 4. 1 plus 4 is 5. And now, hold on, guys. I'm getting a phone call. I do not know who it is, so I'm not going to answer it. All right, so now I'm going to go... I'm going to take this 5, so here's step 2 now. So step 2, I take that 5 and I'm going to subtract the area from 0 to 2, which is 4. 5 minus 4 is 1, so 1's the answer. Ooh, I guess I messed up. Oh, okay, 1 is not the answer. Sorry guys, I almost got it wrong. 1 is the answer from 2 to 4 of this function. I don't want 2 to 4, I want 4 to 2. So, if I'm going to switch the limits, 4 to 2 of f of x dx, I'm going to put a negative on the outside. So since I got 1, the top limit here is 1, or the top integral here, the definite integral, is 1, then if I switch my limits, it's negative 1 because we're counting backwards. So there it is. It's one of the properties, guys. All right, let's look at this one and see if we can game plan. I want the area from 6 to 9. So let's see. I guess I'm gonna have to do 1 of 6, and then no. Okay, I'm gonna have to subtract. So the total area from 1 to 9, and if I subtract the area from 1 to 6, I'm gonna have left over the area from 6 to 9. And if you want to see that visually, guys, write a little graph, not to scale, so you can see what I'm talking about. So if you have the area from 1 to 9 and you subtract the region 1 to 6, you're going to be left with the region 6 to 9. So the area 1 to 9 is this one, 7, minus, and I'm going to subtract the region 1 to 6, which is 4, and 7 minus 4 is 3. And that's it. Right on this one, they want the area 2 to 5, so we got to look at it. So this is what I ultimately want. So let's see. So if I take the area, all right. So here's what we're gonna do. I have the area from 1 to 5, which is 6, and I want the area from 2 to 5. So that means I want to delete the area from 1 to 2. So I'm going to use these two guys right here. So if I have the region from 1 to 4 of f of x, and I delete the region from 2 to 4, let's see if we can do a little visual here. So if I have 1 to 4, so I have all of this, and if I delete, here's 2, if I delete 2 to 4, I'm going to be left with the area from 1 to 2. Yes, that's what I want, and I want that because then I'm going to use this guy. Alright, so this is going to give me the area from 1 to 2. So let's see what that is first. So 1 to 4 is 1, so 1 minus, and then 2 to 4 is 4, so I have negative 3. So that's what this guy is, negative 3. So now I'm going to take the region from 1 to 5 of f of x, and I'm going to subtract the region from 1 to 2, and that's going to give me the region from 2 to 5. So let me draw a little visual so you can see what's up, guys. So here's my little visual, and it's not to scale because obviously there's, not to scale. So if I find my region from 1 to 5, so this is all in green, 1 to 5, and if I subtract the region from 1 to 2, so I'm going to say this is 2, you can see how you're just going to be left with the area from 2 to 5. So I take that negative 3. That negative 3 is the region from 1 to 5. So I'm going to put it right underneath here, guys. And I'm going to subtract this guy right here from 1 to 2. So from 1 to 2, it was... Where were you? Oh, I already messed up. Sorry, guys. I messed up. The area from 1 to 5 is 6. And I'm going to subtract the area from 1 to 2, which is negative 3. And there it is, 9. Hopefully that made sense, guys. If it didn't make sense, ask me again. Or you can, so my apologies for all the errors. I hope I didn't confuse you guys. Hopefully you guys can still vouch for me and give me that thumbs up.
Bye.
Later, Miss Cortez. Miss Cortez said bye to you guys. So, good luck on the quiz, guys. All right, so here we go. The graph f is shown below in the interval negative 5 to negative 3. The area bounded between the graph of f and the x-axis of negative 5 to negative 4 is 10 over 3. So this area right here is 10 over 3. And then the area bounded between negative 4 and 2 is 36. So this area right here is 36. And then the area bounded between the graph of f and the x-axis and 2 to 3 is 10 thirds. So this area here is 10 over 3 again. All right, what do they want? Determine the area between negative 5 and negative 4. Okay. I start at negative 5 and I work my way towards negative 4. And let's see what that is. So I start at negative 5 and I work my way towards negative 4. So I'm just going to have that. It's above the x-axis, so it's just 10 over 3. So 10 over 3. If I were to go all the way to 2, guys, remember that 36 is below the x-axis, so I would have had to subtract. And there it is, guys. We finished the quiz. Hopefully everything made sense. I hope I didn't confuse anyone. And have a good day, and let's get 100 on this quiz. All right, later, guys.